still section 13.3. We're just doing part 2 on 13.3. And we're going to do on Monday we'll work a little more with permutations and combinations. Just want to let you know if it seems a little confusing at first, don't worry, we'll spend a little more time on it. It's a little bit new and it takes a little bit to get used to. So if it's not all 100% clear today, we're going to do a little more work with it, spend a little more time with it. So don't get stressed out about it. Yes. So let's talk about what a permutation is. A permutation is really just an arrangement. Permutation is another way of saying an arrangement. How do we arrange things? And we're picking from a bigger group and making a smaller arrangement. So permutation tells us that if we have n items, or n things, arranged r at a time. So if our class, like in our class we had 30 people and we're arranging them 3 at a time. That would be an example of one type of arrangement. So for a permutation, we have n things r at a time, where order matters. And that's the important thing about permutations. Order matters. The symbol that we use is n PR. And the way we calculate it is n factorial over n minus r.
With the factorial of the n before the b?
Yes. So an example would be, we'll do some calculations in just a second, so we know what this means. So n is the number that we're choosing from. N is the big group. We're choosing from a class of 30 people. R is the number of the smaller group that we're making. So 3 people out of 30. And what we mean by order matters is something like a president, a vice president, and a secretary. If we have 3 people that are president, vice president, and secretary, if we change the order, then a different person is president, a different person is secretary, and a different person is vice president. So even though it's the same 3 people, changing the order changes that group, because every switch we make, a different person is the president, a different person is the vice president. So that's an example where order matters. If we're talking about 10 people in a competition and we're looking at first, second, and third, a different arrangement of people in first, second, and third place is different. So that's where order matters. Even though it's the same 3 people, it's a different arrangement of first, second, and third, so order would matter in those 2 situations. So permutations, the order of the arrangement matters. The order of the arrangement makes a difference to whatever it is that we're looking at. So if we'll do a quick example of a calculation. So we want to evaluate. Some of your homework will say evaluate. Let's say 5P3. So we have a group of 5 things, and we want to arrange them 3 at a time where the order matters. So this would be 5 factorial over 5 minus 3 factorial.
Are you like distributing the factorial?
No. We do the parentheses first.
Oh, and then the answer.
And then we do the fact. So we can't distribute, that's a good question. We cannot distribute the factorial. So we do the parentheses first. So if I rewrote this, this would be 5 factorial divided by 2 factorial. So whatever's in parentheses, we do that first. So let's do it longhand, and then I'll show you on the calculator. So the longhand way is 5 times 4 times 3 times 2 times 1 divided by 2 times 1. I can cancel this with this, and that's just 5 times 4 times 3. And that equals 5 times 4 is 20, times 3 is 60. So if we arrange, and this
What
is
equals 60?
5p3, the number of arrangements of 3 things out of 5 where order matters equals 60. Yeah.
Wait, how did you go through the 2 times 1 if you haven't done the, or do you start with that?
Start with this,
Oh.
and then we can go to this. So I just subtracted the 3 from the 5 to get to this. Okay? Now we can do it a couple of ways in our calculator. So if your calculator has a probability button, like the Texas Instruments, let me clear this. So I had 5p3. So I'm going to do 5, and then I'm going to go to my probability button, my PRB button, and right here I have this says NPR, just like we wrote. I'm going to go down to that button. So I started with my 5, NPR, and then 3. So this is 5 permutations of 3 things. And I hit enter, and I get 60. The other way I could do it is, I'll do it on the other calculator. I can just do I can do 5 factorial divided by 2 factorial equals. So I can just divide. What's that?
Why would you divide?
I am doing what I did there was, my problem was 5 factorial divided by 2 factorial. That's what I did here. So that's just what I put in my calculator. I put exactly this in the calculator. 5 factorial divided by 2 factorial. Okay? So this is how we calculate, that's the 2 ways we can calculate 5 permutations of 5 things taken 3 at a time. If you have trouble using your calculator, you can ask me and I can help you out with it. All right, let's do another example working with permutations. So we have, in our example, we have 10 people in a race. How many ways can they finish in first, second, or third place? So a different arrangement, like I said before, a different arrangement of the 3 people in first, second, and third is a different thing. Joe, John, and Jane finishing first, second, and third is different than Jane, Joe, and John finishing first, second, and third because a different person's in each place. So each different arrangement is different. So this would be an example where order matters. No, that would just 10 times 9 times 8. That would just be the number of different ways we could arrange. Well, does it come out to that? It does come out to that. Yes. So it's kind of like we talked about before, but I want to look at it with permutations, so we can think of it like a permutation. So we're going to use permutations. So we're going to calculate 10p3. 3 things out of 10 in arrangement where order matters. So I get 10 factorial over 10 minus 3 factorial. So I get 10 factorial over 7 factorial. If I write this out the longhand way, 10 times 9 times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1, it's a lot of writing, divided by 7 times 6 times 5, times 4, times 3, times 2, times 1. And what do we cross out? 7 through 1 on the top and the bottom. And what do we come out with? 10 times 9 times 8. So this is the same as, in this case, as using the fundamental counting principle. So we get 90 times 8, which is 720. So we have 720 possible ways that 3 people out of 10 can finish in first, second, or third place. 10p3, 10p3, 10p3 equals 720. That's what we just figured out.
Okay.
Let me write that. I'll write it further over. And I could also do that in my calculator the same way that I just showed you, either using the NPR key or dividing 10 factorial by 7 factorial to get 720. Either of those ways would work in your calculator. And once you get used to how permutations work, you can see that 10 factorial divided by 7 factorial, you'll know that everything from 7 down to 1 is going to cancel, so you just have 10 times 9 times 8. Once you get more used to working with them, you'll be able to see that a little more easily. Questions on permutations? So permutations, we're arranging things where the order matters. The order changes what that group is. All right, let's talk about another way of counting arrangements. And this one is called combinations. I haven't done the attendance yet. I think we have everybody. Okay, so combinations. Combinations are another way of arranging things out of a group. So for combinations, we are arranging n things arranged r at a time, where the order does not matter. And the way we write this is NCR, almost the same, just a little different. N factorial divided by R factorial times N minus R factorial. So the only difference between permutations and combinations is that we divide by this extra R factorial. And the order doesn't matter. And what I mean by an arrangement where the order doesn't matter, can anybody think of an example of an arrangement, how we would arrange things where order would not matter? Anybody think of something that we can choose from a group of things where the order of the things that we choose doesn't matter?
Marbles.
Marbles? So if you have 20 marbles and you're choosing 5, if you have 5 of them in your hand, it doesn't matter what order they're in, right? So that would be a good example. Another one where the things are different, a couple that I can think of, is when you go to Chipotle. You can choose your salsa, you can choose cheese, sour cream, whatever. If you choose hot salsa, lettuce, and cheese, it's the same burrito as if you choose cheese, lettuce, and hot salsa. The arrangement of the things in the burrito doesn't make it a different burrito. It's the same burrito. What's that? So pizza toppings would be another. A pepperoni, sausage, and Canadian bacon pizza is the same as a Canadian bacon, sausage, and pepperoni pizza. The arrangement, the order doesn't matter. So that would be another. Ice cream. So the toppings on an ice cream sundae. We'll do an example of those. So the different arrangement of toppings doesn't make it a different ice cream sundae. It's still the same thing. So
the ice cream first,
you have to do the ice cream first. I'm talking just the toppings.
though. Oh, okay.
Yeah. To understand this better, we should go to
I'm
Chipotle.
looking at computers.
It would help you learn.
Right? Well, you would have to calculate all the different combinations before you could have lunch.
I can do that.
Right. So let's look at a calculation and then we'll do a couple of examples with combinations. So if I want to calculate, let's do 10 C3. We want to calculate that. So this is just going to be 10 factorial over 3 factorial times 10 minus 3 factorial. I'll rewrite that, 10 factorial over 3 factorial times 7 factorial. And if I calculate this out, I end up with 120.
Well, would you do 7 times 3 and then, so since that's 21, would you go 21 times 20 times?
No, so that's a good question. The question was, can you multiply 7 times 3 and then do the factorial? You have to keep these separate. You can't distribute the factorial. So you would do 3 factorial times 7 factorial. Or we could do the trick where we cancel. Let's look at, I'll do it longhand and we'll do the cancellation. You had a question?
Once you do the long hand,
Okay, so I'm going to write this out longhand. So 10 times 9 times 8, all the way down to 1. And I'm going to divide this by, I'm going to put 3 times 2 times 1, and I'm going to put that in parentheses. So let's do something else first. And then I'm going to do 7 factorial. So what's going to be the best one to cross out here?
The 7.
From 7 down to 1. So let's cross that out. So notice I didn't combine anything together yet. So I get 10 times 9 times 8 divided by 3 times 2 times 1. So just divided by 6. And when I calculate this out, I would end up with 120. And I can also plug this into my calculator. I can use, let me show you in the Texas Instruments calculator, with the probability button, you have NCR. So that's what you would use to calculate combinations. So in this case, I would put 10, and I would go to probability. Enter. Whoops, that wasn't what I wanted to do. I want to do this one. There we go. 10, and I want, no, that was P. I want C. So let me start over. There we go. And 3, and I hit enter, and I get 120. So I could do it that way, or the longhand way. Either way works. The other way that we say this, that you can say this symbol, we can say 10, choose 3. So this is 10, choose 3. The combinations we can call the choose function. So 10, choose 3. The difference between permutations and combinations. In combinations, the order doesn't matter. In permutations, the order does. Usually, one way to tell the difference is with permutations, there are more restrictions. So here we're just choosing 3. With a permutation, there'll be another restriction: first, second, and third place, president, vice president, secretary. Usually permutations are more restrictions. There are more conditions on what we're doing. With combinations, there are less restrictions. That's a good way to tell. Permutations have more things that you have to worry about. Most things, I'm going to say, usually what we're working with is combinations. So combinations are usually going to be what you end up with, but not always. Permutations have more restrictions. All right, so let's do, we just did 10, choose 3. So let's look at an example. We're at Chipotle. How many toppings, how many things can you get on your burrito, would you guess, at Chipotle? 20? What's that?
Okay, so
Probably more than all.
they have chicken.
No, not arrangements, but when on the little line, how many toppings can we choose for our burrito? Like 10?
Yeah, I'd say 10. About 10.
Okay, so let's say we have 10 toppings, or 10 burrito fillings. I think we can include the rice. So 10 burrito fillings, and let's say that in order for a burrito to hold together, we're only going to choose 5. We're going to choose 5 fillings. We choose 5. How many different burritos can we have? So the order of the toppings doesn't make it a different burrito, so the order does not matter. So we're going to do combinations. We're going to do 10, choose 5. Yes.
Are we going to have to decide whether or not we have to do combinations or combinations?
On some of the questions, yes. On some of the questions on the homework, it says decide if it's a permutation or combination, and then do the calculation. So some of them you do have to decide. Some of them will just have you calculate, but on some you have to decide. So we're going to do 10 choose 5. I'm going to do 10 factorial over 5 factorial times 10 minus 5 factorial, which is 10 factorial over 5 factorial times 5 factorial. And remember, we don't do 5 times 5 and then do factorial. We do these separately. I'm going to use my calculator for this one, since we did the longhand calculation before. So I'm going to do 10 choose 5. 10. Going to go to the probability. Go down to the choose. Go to 5. Hit enter. And we can order 252 different kinds of burritos. Different kinds of burritos if we have 5 toppings, if we choose 5 toppings out of 10, or 5 fillings.
Yeah.
Double that.
If we were choosing 10 toppings at a time, it would be this number would get even bigger.
Would it be double?
Right.
Would it be double?
Well, let's look. So let's see if we have 10 choose 10. Well, let's think about it. Would it be double at all? If we choose all 10 toppings at once, how many burritos can we make? One kind of burrito, right? We don't even have to calculate. 10 choose 10 is 1.
You're gonna get us with one of those on